So today we're going to see how these critical parameters on the X-ray sensor, the active area, pixel size, ADC, and speed play a role in the performance and the price of the X-ray sensor in your machine. So the key parameters that impact price and performance of an X-ray machine from an X-ray sensor perspective are the active area of the sensor, the pixel size, the ADC of the sensor, and finally the readout speed. So let's break it down and go over each one of those parameters and then go over how they impact parameter and how they impact price. Let's start with the active area. The active area is the size of the detector, right? And for detectors, if you compare detectors with the same pixel size, and all the major parameters I just listed are the same, the larger the active area, the more expensive the detector is going to get. But you get field of view of your sample, right? So if you have an X-ray source here on the bottom, shooting X-ray photons up to this sensor, right? Here's the sensor. And let's say I put my sample right here. That's my PCB, my ballistic plate, my medical device, whatever my sample might be. So let me label this so we don't get lost. And here's our X-ray source. All right, so imagine I have a sensor now that has this active area, right? This large active area. With this sensor and this specific magnification, which is defined by the location where I place the sample between the X-ray source and the sensor, well, with this magnification to set up, I can see this much of my sample, right? That's going to be projected onto the sensor. Now, let's say I go ahead and I select a smaller sensor. Same parameters, but now a smaller sensor. So this smaller sensor, let's imagine that's going to have this. So that's sensor 1. Here's my sensor 2 with a much smaller active area. Now, with this smaller sensor, the projections of the X-ray photons are going to look like this. And as you can see, I'll be able to see a much smaller region of my sample. Again, the same magnification, same resolution, everything else is kept the same, except that instead of being able to see this large portion of my sample, I'll be able to see a much smaller window. So what's the drawback? Price. The larger the sensor, the more expensive they get. In a similar fashion, we have the impact of active areas. One, number 2 is pixel size. Now, pixel size is very interesting. The smaller the pixel, right? So typical sizes range from all the way down to 10 microns, but for most industrial applications, electronics, you're going to be in the 50 micron range. So it's 50 microns. So if this is the pixel on your sensor, you're talking about 50 microns this way, 50 microns that way. That's the size of your pixel. So the smaller the pixel get, the more resolution your image is going to get, right? Because you're going to have more little dots representing that same sample with your imaging. The drawback is price. The resolution, smaller pixels cost more money. It's also good to note that, let's say if I have let's draw a detector right here, right? Let's say it's a detector right here, and I have pixels that are, let's call these pixels 100 microns, okay? 100 by 100. And I have one electron, one X-ray photon that hits here, one X-ray photon that hits here, one X-ray photon hitting this sensor every, call it microsecond, millisecond, whatever that number might be. Now, if with this everything is kept the same, I don't change my magnification with the X-ray source, distances, etc. I keep everything the same, and now I split my pixel by 2, and now I have 50 micron pixels. As you can see, the number of photons that's going to be hit is going to be reduced, right, by half. It's not half, it's actually by 4, because this is 100 by 100. You go 50 by 50 is actually a quarter of the area, not half of the area. But the point is, as you reduce the size of your pixels, your images are going to get darker because fewer X-ray photons are going to be hitting each specific pixel. So that's something to keep in mind. And there are X-ray sources with more power, and we have another video that talks about the parameters, performance, and price for X-ray sources. Check out that video to figure out so you can understand what are the trade-offs from an X-ray source perspective. The next parameter we're going to talk about is the ADC. This is the analog to digital converter. And a lot of people are familiar with 8-bit, 12-bit, 14-bit, 16 bits, right? Most detectors we use today are 16 bits, meaning that you have 65,000 gray scales between white and black, right? And the more shades of gray you had between black and white, or white and black, allow you to get a better, fine-tooth comb, a better idea to separate features within that sample. And then on the other extreme, right, imagine if you have 1 bit, and that's the black and white detector. 1 bit is either 0 or 1, so it's either black and white. You do want to have as many bits as possible. High-resolution sensors usually have 16 bits nowadays, and they give you some beautiful images with quite a bit of depth, because that's what the ADC gives you, that analog to digital converter. The last parameter we talked about is speed. And this speed here is a readout speed. You're collecting a lot of data coming from these detectors. And readout speed is how fast can you pump that data out of the detector. Especially larger detectors or really small detectors have a lot of pixels, a lot of bits that have to be transmitted. And as a result, speed becomes really, really critical parameter. And some CT applications have speed of the sensor as one of the bottlenecks for the performance of the system. And again, the higher the speed, the higher the price that you're going to have to pay. You can get a lower end sensors with a USB-C type of interface, or even the standard USB type of interface, to the higher end detectors or higher end sensors that have fiber optics as a way to read data out of the sensor. So quick review, active area, the bigger the active area, the more you'll be able to see your sample, but also you're going to pay for that. Pixel size, the smaller the pixel, the more points you're going to have to look at your sample, so the better resolution you're going to get. But again, the smaller the pixel size, the higher the price. ADC is that resolution of the image, how many shades of gray your image is going to have. The more bits you have, the better off you're going to be, but also you're going to pay for that, the higher the price is going to get. And finally, the speed. The higher the speed, the more efficiently you can pump data out of the sensor, the better you're going to be. You're going to have a closer to real-time view of your images, especially if you're doing a computer tomography or 3D. And again, you got to pay more money for that. So I hope we'll be able to give a quick glance of how these critical parameters play a role in the performance and pricing of your X-ray machine. And again, do not forget to subscribe. And if you have any other questions, reach out to us at creativeelectron.com. Thanks for watching.